So good morning. It's Thursday, 10/14, and we're going to work on lesson 2.8, page 239. And then at the end of this recording, if you are not live, at the end of this recording, there will be questions if anybody has them on the worksheet. So if you want to skip forward or watch along. So we're going to go ahead to 2.8. This is kind of a wrap up lesson on everything we've done in unit 2. So we're on page 239, keeping it current. So this says, if you're like many students, you're concerned with the cost of attending college. It's certainly not a secret that college tuition has been rising rapidly over the last 20 to 30 years. But what are the facts? For that, we need some data. The following table lists the average cost of tuition and required fees for all four-year American colleges and universities for a variety of schools started in 1980. So we have some data there. And you can go ahead and flip to the next page. So we're going to need this table because on the next page, they talk about analyzing data with patterns, which we've been doing. And then it says we're going to talk about the fact that our years, we mentioned earlier this semester or in unit 2, that the years are too big for our scaling. So we usually have a base year. And so it says 1980 is going to be our base year. So the first value here in X is going to be years since 1980. And then we're going to call that X1 in Desmos. And the cost of tuition, the average cost of tuition for that year is going to be Y1. So the first one is going to be 1679. So either you can fill them in here, which I do suggest, but then we're going to go ahead and put it in Desmos as well. I'm going to leave this page up on my screen for now so that everybody can, because yours is flipped too. So otherwise you got to keep flipping back and forth. So I'll have mine up so everybody read my table, okay? And then you can go ahead and fill in your table on your page, and then we'll go to Desmos from there. Okay, so if you hopefully we're able to get your data into years since 1980. And also hopefully you notice that it went from 0, 10, 20, 30, and then all of a sudden it went by 1. So 31 through 37. And then Y1, we have our average tuition costs. And then we always like to make a scatter plot to look at the data. And it's asking you that too on number 3, based on your scatter plot, which type of equation do you think best fits the data? So I'm going to go ahead and hit my magnifying glass so I can see the scaling and see my data. And does anybody have any ideas? What are your initial thoughts? Now, if you've already done your modeling, if you're ahead of me, just go back to just looking at the scatter plot. So what's everybody's initial thoughts on what type of model do you think is going to best fit this data?
It looks pretty linear.
It does look pretty linear, I think. When I looked at mine, it looks like I'm looking away from you because I'm looking at my other screen. But so right here on, you all can see my decimals, right? That's what I have on. So the first 3 data points look, I think, very linear like this. And then these kind of look linear up here. But then, I don't know, they kind of maybe look like they curve. So I kind of went with, I'm kind of open. I'm not really sure. What have, can anybody tell me what piece of what we've learned in Unit 2 do you think maybe can help us decide best which one will be for us for this data set?
Is it the correlation coefficient?
Excellent. So they're kind of going to walk you through it on here, but if you're feeling confident about, what you're doing as far as modeling, we're basically going to do some modeling. I'm going to go to line number 2 here, and I'm going to do my modeling for a line of best fit. So I'm just going to kind of keep it all right here. I'm not going to necessarily go through and answer every question by question, but I'm going to kind of do it as like a statistician would. So I'm going to say, I'm going to find my line of best fit to see if it is linear using the R correlation. I think oh gosh, now my fingers are all over the place. Okay, so y1 tilde mx1 plus b gets us the line of best fit. And what do y'all think? I think it looks pretty good. Our correlation coefficient is 0.995. So I'm going to make a note here. Our R is equal to 0.9915. Oops. Which is very good. So linear is a good fit. Okay. So that's the first thing that I would do there. And that answers 3. 4 gives you the line of best fit. We graphed it. And then 6 is asking for the correlation coefficient. So I'm going to just go to my paper for number 4 for just a minute, because I want to make sure everybody knows how to find the parameters from. So right now you're seeing my Desmo screen. The parameters for a linear are the M and the B. They're the slope and your y-intercept, and you need those right here where my mouse is on the screen. Those parameters are what you need to fill in basically your equation or your recipe for a linear model. Okay. So when we go back to our paper, that's what they wanted us to do on number 4 here, was find the linear equation of line, the best fit line. So we came up with this 414.94x plus 574.80 when we round appropriately, because it's in dollars, right? Did everybody get that on theirs?
Yeah.
Okay, good. I want to make sure everybody's got the same thing. Okay, so then, as a statistician, we are going to go ahead and say, well, what about, oh wait, let's look at number 7 while we're here. So number 7 says, okay, so we think linear looks pretty good. 5 is looking at the graph. 6 is the correlation coefficient, which we already said is pretty amazing. Okay, and then we go to 7, write a description of what the slope of your linear model tells us about the growth of tuition since 1980. Be very specific. So this is yet another practice for interpreting slope. Lots of students it's just a kind of a weird concept, this interpretation. But this is what we need to be able to do from this math class. And so our slope is our change in y over change in x. You should be writing this every time. And then my units for y on top, my y units, right? If we go and look at an xy coordinate, can somebody tell me what are my x and y units? We go back to our table of data. What are the units of our x and y? This is what you need to know to be able to interpret slope. So you're gonna go back here. So X is your school years, right? And up here, we said X is your year since 1990. So right here is gonna be years since 1980. And then Y is the cost of college. Says Y value should be the average tuition cost. So average tuition cost, okay? And what we can see is that with our slope being 414.94 over 1, right? Then my 1 is changing, my years is what it's saying, my years are changing from 1980. And when they change by 1, my average tuition cost is changing by $414.94. And it's positive, so that means it's increasing, right? It's going up, up, up. Okay, so we're just gonna write that in a sentence, everything we just walked through. So each year, so if I write each year, that describes my change in X. So let's just say each year since 1980, so we know our reference year, we can expect the average tuition cost to increase by $414.94. You could have even started with right here. We can expect the average cost of tuition to increase by $414.94 each year. So you just have to make sure that you're telling me that each year that the X's are changing. Okay, now back to the Desmos, because now they're like, well, okay, so let's just go and look at the exponential model of best fit. So we're going to find the exponential model of best fit. So we're going to type in y1 tilde a times b to the x1. And then we're going to come back and write down what that is. So let's go back to Desmos and see what that looks like. So here we have y1 tilde a times b to the x1. Oops, I missed a parentheses. Oh, because I'm gonna put, I forgot. I had a note here. So I'm just gonna make a note. We are going to find the exponential equation of best fit for the line. Okay, so y1 tilde a times b to the x1. Oh gosh, there. Me and my parentheses here today. There we go. And we have to remember that when we do the log, the exponential model, we have to click on the log mode box or it won't give us the R. So there it is. Our parameters A and B. So A is 1976.34 and B is 1.06173 to the X. So go ahead and jot that down on your number 8. And we need the R correlation coefficient for number 11, which is the lesson check. So number 11 is your lesson check. R is equal to 0.991. I'm going to go back to my page here for a minute. So here's my paper. Here is my exponential equation of best fit. Does anybody that's live have any questions on how we got that? And I promise, if you're not spending a little bit of time every day or every other day, the more you spend a little bit of time just typing this in and hit the X and delete it in Desmos and type it again. It's just like doing anything in life. You didn't become good at riding a bike, right? Until you rode and you were wobbly and then you fell a couple times maybe, or then you're like, oh, your mind's like, oh, I've got to get my balance, right? And then you're like, okay, so next time you're really working on your balance. And then it's like, oh, I got to pedal faster to keep my balance and keep myself up. But you didn't learn all those things unless you kept trying to ride the bike or play a video game, right? Or a sport or an instrument. So it's the same with this. If you're feeling like, I just can't do this, or man, that's not my subject, I can guarantee you will feel more confident if you just keep trying it. And if you're like, I think I'm writing my, interpretation of slope right, but I'm not sure, send me an email and just copy what you think, type it up and just say, Mrs. Main, this is how I think I'm interpreting slope. I'm not going to go, oh my gosh, you're not a smart person. I'm going to say, oh, this is what you did well in that sentence, and this is how you can improve, right? I'm happy. It's not a secret. The worksheets are not a secret. I just want you to learn something from this class. So by all means, ask questions. Okay, everybody's with me so far. I'm off my soapbox. So it says, write a description of what the base of the exponent in your exponential model tells us about the growth of tuition since 1980. Okay, the base of the exponent is our B, which is our growth factor. And the one for this model is 1.06173. This is our multiplier, right? This is our multiplier. But to figure out what does that tell us? Well, from one output to the next, I'm going to multiply by 1.06173 to get the next one. But I want to know, like, it looks like it's growing because I can see that from my Desmos. So it's a growth, right? It's exponential growth. So I want to find my relative increase, my relative growth. And to do that, you are always going to just take your B and subtract 1. Okay. Now, if your relative growth is positive, it means it's growing. If it comes out negative, it means you actually have decay, and you should see that in your graph. So your graph should give you some indication. So I'm going to take my B, which is 1.06173, and subtract 1. And if you're like, oh gosh, I've eyeballed it and I keep messing it up, just type it in your calculator. 1.06173 minus 1. You have left 0.06173 multiplied by 100 to put it into percent form, right? Or move our decimal 2 places to the right. So 6.173% increase each year. And I'm saying each year because our X is year since 1980. And you can even write each year since 1980. This is also a rate of change. Just like our slope is a linear rate of change, this is our exponential rate of change, right? 6.173%. Okay. Want to make sure everybody has this for their lesson check. In the lesson check, it does ask for in 2 decimal places. So if you just do 0.99, that should be good for the lesson check. The last question for Unit 2 lessons, all of Unit 2, is which one do we choose? Which one do you think is the best and why?
I personally think the linear one is better. The correlation coefficient is just very, very slightly better. But looking into the future as well, the exponential model probably won't fit as well based on what our data is telling us.
I would agree. And I think it's pretty obvious when you look at the graph. The linear, even though it's a little bit, the slope is just different in the first 1980. It's still growing linearly. It's just kind of been raised a little bit. I definitely think that if we went with the exponential model and started using it to make some predictions, we would be way over predicting for sure. So that's what you're going to tell me here. You're going to tell me your choice and why. So I would choose linear based on two things. The scatter plot. And then the main thing is my R, my correlation coefficient. Is the best for a linear model. So that would be my choice too. Anybody have any questions? So let's talk a little bit about the midterm. So hopefully everybody received my email and you read my email and you clicked on the link and you chose a day and time that works best for you. Then I know when you're taking the midterm. So the midterm will be, you'll log into the Zoom on that day. All of my Zoom links are the same. It doesn't matter what class you're in. I have one Zoom link so that everybody can just come see me. You'll log into the Zoom. When you're in the Zoom, I'll say, hi, Kelsey, here to take the midterm. Yep. And then I'll say, okay, do you have your note sheets? So you can have two note sheets, front and back, whatever. I would highly suggest the percent increase or percent change, percent error, right? They're all the same thing. I would have that. I would have some number examples to go with it, not just an answer, but like how you got there. What was the new number? What was the old number? All that good stuff. So you're going to have those with you. Yes, you can use Desmos, most certainly. So I would prefer that people log into the Zoom with their phone, so their phone can be propped up so I can see you on your device. Because what I'll do is once Kelsey's like, yep, I'm here are my note sheets, I'm going to take my midterm, I'm going to email everybody the midterm. So I was going to do it using Respondus and JetNet, but it's kind of confusing. Not everybody can get it on their device. And then there's no real way for you to show your work. So this is how I'm doing it. So I'll email you the document. It's a Microsoft Word document. So you can either type your answers in Microsoft Word. You can print out your midterm if you want to print it out and just say, Mrs. Main, I got to print out. So I'll run to my printer and grab it, whatever. You can print it out and write your answers and scan it and upload it just like we do for your worksheets. If you'd rather just have Microsoft Word, the midterm pulled up on your screen and you just want to write your answers on your own paper and scan those and upload those, that's fine. If you want to write some on paper and do some in Desmos, because some of it is going to be like kind of Desmos work where you're going to have data set. Maybe do something kind of like what we did today, where you're going through the different modeling and you want to save it. And then in the midterm, you can upload up to 20 documents, which you shouldn't need. And those include either a Microsoft Word document, a PDF, a scanned piece of paper, a Desmos link. So all of those. If you want to have a calculator as well, but I do need to be able to see your workspace. So at any time during the midterm, I could say, hey, Kelsey, can you just show me your workspace? I just want to make sure it kind of looks like you might be on your phone. I trust that my students aren't trying to cheat, but I have to kind of cover for that. Does that answer your questions about midterms? I hope. Yay. Yep. So I think I made myself pretty available. So it'll be not this weekend Sunday, but like the next weekend Sunday. I think it might be the 24th. There's times on that Monday because my in-person class is taking theirs. So I made a chunk of time that day. And then Tuesday I'm wide open because I had the morning class and the evening class. So I made times that day. So if you cannot make any of those times, that's also a choice in the Google form that I sent out, the little survey thing. So. We're working on halfway. I think this week is halfway through the semester. After this week, we're over halfway through the semester, which is exciting. You've made it through Unit 2. Make sure you're working on that Unit 2 project. And I've got the Unit 1 reviews finally graded. I had to print them out just to save time. So I didn't type feedback in JetNet. So if you want some specific feedback, let me know, and I'm happy to email that. What I'm probably going to do is just make a video that kind of goes through all of the Unit 1 review kind of answers and points out places where people made mistakes. And then if you want to figure out where you made mistakes, you could go back through and look at your unit review versus what the correct answers were to see if you got those right or wrong. I'm happy to do that. Or if you want to email me and just say, what problems did I miss? I can tell you those, and then you can go back through my video. So I'm going to make that next week, a video going through the Unit 1 review answer key. Then I will be plugging along on the Unit 1 projects. Those are going to be slowly but surely because I want to start getting to the rest of your Unit 2 worksheets and getting as much of those done before you take your midterm. It's my goal to have those all caught up. So anybody else staying on to ask questions for worksheets, working, whatnot?
Yeah, I'm gonna stay on for a bit.
Okay.
For the 2.8 worksheet, I don't see one. I just see a 2.7 worksheet.
That may just be it. Yes, it's 3 pages. So oh wait, it's 2 pages. So I don't see one either. So I'm glad you brought that up. There isn't one. I'm going to go delete that right now. Thank you for bringing that up. We better hop to it. Did you have another question?
Yes, so my other question was on the Unit 2 project for task 1.
Mm-hmm.
In the Desmos thing, and I don't know if you've talked about this already, but there's a question that just isn't finished.
Oh, maybe something got, yikes. Maybe something. Oh no. Which one is it?
It's,
Oh, using the model that you believe to be the better fit, provide the,
yeah,
maybe I should make it using the model that you believe to be the better fit. I'm trying to think what I had here. Correlation coefficient, which models have you? I'm gonna say type out the equation. Okay, so I'm gonna hit save. And I'm gonna get out of Desmos. Can you go in and click on that and see what you see? Because I've never done it where I've modified something and then I don't know if I need to put a new link. I hope not.
oh, okay, yeah, one sec.
Keep your fingers crossed for me. I sure hope not.
I refreshed and it did not change.
No. That stinks. Hmm. Oh, you know what? It's just the 2.7 worksheet is replacing the 2.8 worksheet. That's what that is. So I'll put that back in. Fudge. I'm gonna have to go and sadly, nobody's asked me about that, which is even more sad. So what did is that the 26th or the 20? What is that Tuesday? The day of our exam, 24, 25, 26. Okay. You know what? Let's just, why don't we just skip it? If someone brings it up, I'll just tell them to delete it. But you know what? I just opened this up and I didn't save it either. Which is interesting. Maybe it didn't save. Let me try this again. Using the math. Okay, try it again, if you would. And if not, I'm just gonna delete it.
Yeah, I refreshed and it's still not there.
And it's still not there. Okay, then just disregard it. I just want you to put together the slope and the y-intercept and type it out. But as long as you're, providing your slope and answering the other questions and the y-intercept, you're you're still answering the questions that you need.
Okay.
So it's fine. Okay, so question on the 2-6 worksheet question number 3, right, Stephen?
Yeah, question number 3.
Okay, so on this data, even though it's a 2-6 worksheet, it's essentially kind of comparing linear modeling, line of best fit, and the exponential modeling. So if you put both in, I essentially want you to choose, is it linear or exponential in part A? So it sounds like Stephen chose exponential. And so we're going to explain the growth factor. Is that what you're asking, Stephen?
Yes. Does it want us to do like, because the question C asks to identify the slope too? Does it want us to do both, or does it want us just to do the one that we found?
Whichever one you chose. So it says if you chose the exponential model, then explain your growth factor. If you chose the linear model, then explain your slope.
Okay, that
Yeah.
makes more sense.
So basically, whichever one you chose, explain your rate of change.
Okay,
Yeah,
thank you.
you're welcome. Great question. So on that same question, number 3 on the 2.6 worksheet, let me share my screen again. It's asking you to use whatever model you chose, use that to predict the population that is foreign born in 2016. Then just change this to be 2016. I don't know what it was in 2016, but change this to be 2016. So you should be comparing the same. The error should be compared to the same year. So sorry about that. Corrected.
I didn't.
So go ahead, hon.
I use this website called Sejda, and it's like an online PDF editor, and you can like put clickable links in the PDF. And for me, it works, but I don't know if it worked after I turned it in.
Okay, I don't see anything on page 1. Don't see anything on page 2, and I don't see anything on page 3. Unless that's what's
I
coming up
put-
on the screen.
Let me download it real quick.
Okay,
Um,
let me see. So I can do it if I click on the link. The only thing is, that will work. You've already done it like that. It's not the end of the world. Because that's what is going to happen to the same thing. And I can edit the rest of your worksheet. It's just when people do that, never mind. It's totally fine how you have yours up there, Stephen.
okay, because you're muted too.
Sure. What's your question? Sorry about that. 2-7. This one?
Yes. Yeah. So, unless I'm just wasn't thinking about it right, how do we write the debt in billions? Because after a certain number of years, it goes up to trillions.
Right. So you can still say, so like, for instance, this one is 257. You could say 0.4 billion. You could even just do 257 billion. This one would be 255 billion, right? And then right here, we get to the trillions, because this is the hundreds, thousands, millions, billions, trillions. So you'll just write it as billions still. So it'd be 1,572 billion.
Okay.
Yep. I know it feels kind of weird.
Yeah.
I'm with you.
Thank you.
You are very welcome.